calibration parameters. So which one to choose or to select for calibration? We have selected also, we have modified the configuration with 5. Se va a agarrar. Se llama, everything is to be set, you know. So we have also checked the path, and we have we did also we brought our calibration, observed flow here and tested it here, and we brought also our analysis to the text in out path. That's all the initial procedure for doing calibration. Okay. So you go one step back in Apex View. Okay. One step back, and you can double click the Apex View application here. Or it's also the same if you open the Apex View from here from your list of application. So you double click here. So these are the tool for automatic calibration. We have 3 methods: Morris, Soko, and fast methods. So you can read more about the 3 different types of sensitivity analysis. Okay, the Morris method is the one which is similar to one at a time, or AT sensitivity analysis. If you remember in SWOT there is one at a time, so it's going to evaluate one parameter at a time and see the effect on the output parameter. And you can use the rest as well. So you just select Morris and then do a run. So you provide all information, then now it should run. And make sure that the Apex Qt, the Apex editor needs to be closed. Otherwise it will crash. So now it is running. So even we reduce the number to 50, the total number of iteration is now 6. Apex needs to iterate for 700 times. So if you are starting, so we'll be around for this. How many of you successfully run this? It's not running. It's running. Running. Yeah. What else is running? Huh? Did you run? No.
ብዙ ሶፍትዌር አለ አታጠፋም ተጠቅማ አታጠፋም እሱን ልምድ ልማድ እኔ አሁን ኤርድራስ አለኝ እጠቀማለሁ ስፈልግ እችላለሁ ሳልፈልግ አጠፋዋለሁ ያኔ ኮምፒውተር በጣም ቢዚ ሆነ ሰላሳ አምስት ሆነ እሱ ይፈታል ከሱ ራሱ ፈታ ከአንተ ራሱ ፈጠነ ኮምፒውተር
ኮምፒውተራቸው ይፈትናል።
የኔ ገና ተኝታለች።
ሶፍትዌር አጠፋለሁ ነው ለዛ ነው።
አሲ ላይ
አዎ
አዲስ ተሞክሯል።
ማለት
እዚህ አካባቢ በደንብ እየሄደ ወደዚህ አካባቢ ወደዛ ብትበተን
አንበተንም በመጨረሻ ሰዓት አላረግም
ችግሩ እንትን ረን ያደረጉ ሰው ከሆነ ችግር የለም። ፕሮጀክት ራሱ ረን ያደረገ ፕሮጀክት ያላቸው ደግሞ ካሊብሬት
Just close it. So you go to project. The project. Okay, there is Morris indices.
ያ
Can check those Morris indices. Open them. Now you can see a value associated with the selected parameters. Okay. So there is no threshold value to ignore parameters. But literature says if they have this value shows the relative influence of the parameters to the output variable. So the higher the value is showing, the higher the influence. Okay. So since there is no threshold value, agreed threshold value, you can incorporate those parameters we have a value greater than 0, for example, as sensitive parameter and use them for your calibration. Okay. So what we are going to do is we are going to remove this, and parameter 42 and 42. And let's keep the other parameters. Since these parameters are small, you can use all of them for calibration. The purpose of sensitivity analysis is just to minimize the parameter for calibration. But what we are going to do is we go back to calibration parameter. Okay? Go back to calibration parameter we have set here. Then make this 0. For number now, we make it 0. And the other Sato, should I use let me use the filter. Value. So we have this number, Sato parameter 41 and 42. Sato. So we make this value to 0. Because they are not sensitive for now. And we remove the filter and say the values. Okay. So now we are done with that. So you go back again to the one folder behind the Apex queue. You need the Apex queue, and the DDS method is the only method for calibration. Okay, I have some notes for this if you like. I will share you. Yes, documents. So these are the different techniques. So for Morris, as I said, for uh, one at a time, and so for is variance-based sensitivity analysis. Okay, and there is fast also Fourier amplitude sensitivity analysis. And DDS is a global optimization algorithm. They call it dynamical dimension search. So you may further read about this dynamically dimension search algorithm. It is a new one based on the previous calibration algorithm. They have developed this one based on the limitation of the previous uh, calibration. So now we run this calibration.
అవును జరుగు అవును
Once you finish it, you can close it. And go to the folder. So we need to combine two files in order to see our result for this small simulation. One is the DDS out file, and the other is the module performance. So let's see the module performance, for example. So you have this number of runs. Okay. Let us copy everything. Control F and Control C. Okay. And let's go to Excel and put it there. So you can bring data text column like the one we did yesterday. Finish. Now this is the run number, and these are the different performance levels. Okay, so we focus. Now you can see that the values depends is different for the different runs. So we highlight the data for filter. I mean, we filter here and see. Let's select the maximum value of 9. You can see up to 994 value is there. Let's select at least values more than 0.9. So 9 more than 90% is achieved in run number 11 and run number 16. Okay, run number 11 looks higher, more efficiency. So what are the parameter values at this run number 11 is the second file. We need to bring the second file to see which are the parameters associated with this highest efficiency. Okay, so we go to DDS out, open it. These are the run numbers and the associated parameter values. So make copy of all and let us bring it here in Excel and do next column. And this is the model run. From the previous file, we have seen that 11 and 16 run number 11 and 16 provides the maximum efficiency, right? So we select the run numbers, those run numbers from here. So we are interested in the run number 11 and 66. Just 60 or 66? 16. Let me go up. 66. 11 and 66. It's 11 and 66. And you can see that for this efficiency in run number 11, the parameter values are this one. You know, so for those parameters that we consider for calibration. For run number 66, the parameter values are this one. Both parameter values produce a very reasonable result. So, of course, run number 11 has highest performance. So, this is how you do automatic calibration. And then, what do you do after you get this parameter value? So, you go back to your folder and then in the parameter and other files, you edit the value to this calibrated values. Is that clear or confusing?
Clear.
Clear. So now I would like you to replace the value of this parameter in the folder and see and provide the simulated result based on the calibrated value. You know that we had an observed flow here. I would like you to provide the simulation, okay, here with a calibrated value, automatically calibrated value. Auto simulation 1. Let's bring this value. So what do you do? Let's do it together. So I gave you the we already gave you the the training manual. The calibration we have applied this value, right? Let's copy it so that we can have a backup. Let's copy this and create a new folder, calibration, calibration for flow, let's say, and put the entire value over there. Now you can see this is the initial value. Okay, the value, if you take out the flow from here, it is the initial value. So we didn't still integrate the calibrated parameter. So in this new folder, you can open the Apex editor, and then we are interested to put the value here, these values. The values in the yellow. So we have FEM, you know, where is FEM is found. You can look to uh, your this one is the user manual or the one that we provide you for the training manuals. So FEM is found in the file, the site file, .cit file. Okay, so I'm going there. So this is the .site file. Go to get site and then read the value. So look for parameter called FEM. Where is FEM? Here. Peak run operate rainfall energy adjustment factor. So this one from the calibration value what we got was 0.425. So initially it was 0.97. Okay, the value range from 0 to 1. So let's provide this for 0.425 here. 0.425 and right here. Right. Okay, we correct one parameter. The other is the RFTO. Let's see where that is located in. RFTO is located in the control file, Apex control file. It is the groundwater residence time in days. So you go to the control file, get files, read. So look for RFTO. Here is RFTO. The value is 34 initially. Now it comes with 20, right? 20.0 something. 20.045. So, and then you write it. Third parameter is parameter 12. So this, any parameters that start with farm is located in the parameter file. But there is one here, RFTO. Initially it was RFTO, right? RFTO, now there is RFTO. That is still in the control file. Is a fraction of return flow to the summation of return flow and incorporation. So RFPO is still in the control file. You go to the control file and then look for RFPO. RFPO here, and the value that we get is 0.88, that is not 0.11, 0.11, and you write it. The other parameters here, from parameter 12 to parameter 92, all of them are found in the parameter file. So let's go to the Apex editor and go to harm of that. Let's do get files and read it first. And we have parameter 12. Parameter 12 was found to be 2.154. It was 2.3, now it is 2.154.
Lines.
What?
Lines or two line, no?
This one. The parameter. These are the parameter numbers.
Okay.
So parameter 12 is here. You go to, this is a parameter, in bracket is n, parameter 12 means this one. And the other is parameter 20.057. It was 0.05, then we add 7 after 5. And the other is parameter 40, that is 0.758. Go to 40.758. 0.758. It was ground storage before. And parameter 49, 7.31. 49, it was 7 initially, now it was 7.31, 0.312. And parameter, which one is it? 49, right?
Yeah.
The other is parameter
40.
90.
Yeah, 90.
90, 41.723. Go to 90, this will be 41.723. 723. And the other is parameter 92, the last one, 0.954. Here was 0.954 is a new value. So now we are done with all, and we need to write it. So we have adjusted all the parameters that we use for calibration in our file, and we make a run of it.
What about the test off and the base off?
That's not parameter.
Okay.
Yeah, that's not parameter. That is just trial for the calibration. Yeah. Parameter things up to here. So you can run it now. Okay. Now we are running it with the calibrated parameters. Then let's bring the ASF file. Okay. So let's have the water yield. Let's copy the water yield and go to our observation and let's put it here. This is after auto calibration. Okay, we can have here also the first simulation without calibration, right? First simulation, or you can say before calibration. Before calibration, since we have changed the values here in the calibration flow, I'm going to bring it from the original RFX side run. Okay, from the original file to get the initial run. So I go here SFI and that's the water here. Oh, so the first initial run.
Ah, yes. 2001 is the first thing. Observed is the one.
So where is the observed thing? So this looks the simulation. So the observed flow. So we have to do it from here.
Can you check the observed sim one?
Observed schema.
Yeah, Fatih made it. This one, yeah.
Okay.
This 42 is observed.
So what is this is observed?
Yeah, yeah, I'm sure.
So this is observed. So if this is observed, then we should have give this into calibration point. You did very well, right?
Yeah.
Good. So you provide this value.
Yeah,
Fine.
yeah.
So we provide the simulation during calibration. So now if you close these two, that this is observed value, this is the initial simulation, and after calibration simulation looks the same because we use this observed value. I mean this observed value as observed value, but it is the initial run to calibrate the model. Okay. So you can so this is how you do it, but you can use this into your calibration. Okay, use this into your calibration. Uh, that is here. The apex keyword. We took that observed yearly flow, right? In the morning, you remember?
Yeah.
So we took this. This is the light simulated flow. So the observed flow is like this. Okay. So you can save this and do the calibration again. So what what's changing is just observable part. So now you can close the Apex editor and then go to the Apex Qt again and do the calibration. So if you have done it already, yeah, ፕሮሲዲዩር ተመሳሳይ ነው። ግን ምንድነው የመጀመሪያ ሲሙሌሽን ስላየው የዛ ሲሙሌሽን ራሱ ሴንሲቲቪቲ ከፍ ማድረግ ይችላል። የራሱን ሲሙሌሽን ስለሆነ የትኛው አፌክት ያደርገዋል የሚለው Are you trying it? From the morning? Okay. So far, they think we need to repeat it. Start.
Please take notes, okay? You see that before you do the calibration, there are 5 important things that you have to do. Just note them down. Where do I move this to? So you know that your testing out file, you have to clear everything. And go and bring your files from calibration and test it. You can test it by running. If it works, then it means everything is fine there. Before you go on to changing the parameters. So you can put down notes, just bullet points. It helps. Otherwise, it will be confusing.
So before starting calibration, so these are the steps that we need to do. So in the Apex Qt file, this can do both sensitivity analysis and calibration. In the tool setting, we need to modify things, right? Maximum number of iterations, number of runs, sensitivity analysis. In the calibration file, this one you have it already. In the calibration file, you need to modify, you need to choose which calibration parameter that you would like to include. Okay. And in the config.dat file, okay, you need to provide the path that you are calibrating. In the text in-house folder, you need to bring your text in-house file that you run from the model. and this is the directory. Okay, and this is hydrology 1 yearly data is the one that we use to put our annual data, annual observed data. So, and this is where to copy the address, and this is the one that we use after calibration. And Morris index is used to see which parameters are more significant. Okay, this you need to keep this in your mind. Okay. So you can see that now, for example, this is before calibration. This one. So you can see that the model overestimates, right? Even after calibration, you might get with this thing, but once you got some approach to the automatic calibration, you can fine tune using again manual calibration also on few selected parameters. Okay. So who is controlling runoff? We have said that before. Okay, so mostly the peak runoff uh, and other things are not well adjusted now. So the first thing we do, we go to Apex Skills folder and project. So there is a folder called OBS, that is observed file. You go there, and for annual hydrological balance, we use height yearly, and for sub area 1 or which one, we use the one with at the end, the value that has 1. And in this value, you copy your observed data from here, you copy this and paste special values. The rest will be negative 999 because I don't have the data or I don't want to calibrate with those variables. And this data runs from 1984 to 2012. Once you have done that, you can save it and close. Is it good up to this?
I think in the Excel,
So,
no, this one.
did
The
you,
first one.
the calibration folder, this one is in the training material calibration folder. There is calibration folder, and there is a text side here for the text in out, but the observable one is here. Observable flow statement in here. Got it? Is it good so far? No response? Shall we continue or shall we repeat this one again? Continue or repeat?
This one, sir.
What? Repeat once? Okay. So the Apex Key projects folder, there is observer where you put your observer data. Go there. There are files for daily, monthly, and annual. Select the yearly hydrological data. And in this file, you can provide a value of observed flow in millimeter per second. So it starts from 1984 1984. This value will be negative 999, and here we bring from the observed data here. This is the observed flow. So you can copy this and paste it here.
The year starts from 1990.
1998, so you change 1988 to 1984 and 1985. So our data starts from 1984. Yeah. So you can copy both the year and the observed data and paste it here. And then we can move on. You got the idea of calibration.
Yeah.
With the speed.
They want to do project 7.
Chapter 12, 11, 12, 12.